Hello, and welcome to my project. This is the Maskbot robot, and its purpose is to facilitate the traffic through an indoor area, based on whether or not passerby are wearing masks, or if their body temperature is at or under 37.8 degrees Celsius. I have initialized the program, and as you can see, the USB camera is already streaming to the Raspberry Pi. So I'm going to quickly go over what this project is and its various components. I'll start with the chassis. The chassis is composed of wooden boards which I have screwed together, and they form the body which is going to house the Raspberry Pi. You can see the Raspberry Pi in there. It's a Raspberry Pi 4B+ model, and you can see that this wire at the back extends upwards right over here to this USB camera, which is showing myself on the screen right now. This Raspberry Pi is also connected to this LCD, a 16:2 LCD. And its purpose is to display messages to passerby. Right now it's detecting my mask, so it's telling me to please proceed, and it's also showing the current temperature. If I place my hand in front of this infrared thermometer, it's going to give me my current temperature, which is 35 degrees Celsius. And you can see the wiring right here. That is also connected to the Raspberry Pi. The next components that are connected to the Raspberry Pi are these LEDs. Just a typical standard red and green LED, which pull a current of 20 milliamps. And you can see that these two extend to the Raspberry Pi, but not before being connected to current limiting resistors, which have values which correspond to the current limiting resistor equation, which is supply voltage minus forward voltage divided by the current that you need the LEDs to pull. Additionally, I forgot to mention these two potentiometers. They're used to vary the contrast voltage and also the backlight voltage. The last component that I want to talk about is this ultrasonic sensor. This is the only component that's embedded in the chassis which is not controlled by the Raspberry Pi. This ultrasonic sensor is actually controlled by this Arduino Uno right over here. And this Arduino Uno controls the servos to the entrance gate. This is the entrance gate where traffic will be incoming. And you could probably hear that buzzer go off quite a few times. And that's because right now there is no passerby coming to the chassis. But this buzzer is connected to the Arduino Uno, as is this power supply, which I need to use because I have to have the Arduino Uno be in closer proximity to the servos that it controls, because if the Arduino Uno is too far away, the wires have to be longer, and the signal which I'm sending to the servos gets distorted, and I don't get clean movements. And in fact, sometimes they hardly move at all. But you can see here that I have two lines. This line right here actually connects to the Raspberry Pi, and it sends a signal to the Arduino if there is a mask status, unmasked status, hot temperature status, or well, actually there's only a hot temperature status, and that signal pin is going to be 5 for the unmasked mask status, and 2 for the buzzer. So the Raspberry Pi will actually send a high signal from, I believe it's the 16, pin 16, or GPIO 16. Alright, so that pretty much wraps up this entrance gate. To summarize, this will open up or close based on the mask status and the temperature status acquired by the Raspberry Pi over here. So you can see I'm standing in front with my mask on, and the servos have raised. This is the exit gate. So the way this works is, after I had passed through the entrance gate, I would eventually make my way, hypothetically, back to this gate to come out, say out of a hallway, for instance. And this is actually completely disconnected from the Raspberry Pi. So this buzzer is getting a bit annoying. So what I'll do is I will turn off the Raspberry Pi for right now. Alright, so now it's off. Now I'll unplug this guy. So the last big piece of my project here is the exit gate. And the exit gate, as I said before, is completely disconnected from the Raspberry Pi. So I'm just going to slip around here because it will not open from the side. There is no way to actually enter from the side. So let me come around back from here. And I don't know how well you can hear it from my recording device, but you can actually hear the buzz of the servos. And that's because actively at all times they're being held at a horizontal position every few milliseconds. So the way that this works, we have another Arduino Uno right here. We have a battery pack that's powering it, again to make sure that the Arduino Uno is not too far away from the servos, because if the wires are too long, then the signal gets a bit corrupted. So you can see here we have an ultrasonic sensor, another one, and this ultrasonic sensor is how we get the servos to go up or down. So if you put your hand in front of this ultrasonic sensor at a distance of less than or equal to 10 centimeters, these arms will raise. So I'll show you that right now. And they have risen. And I'm using a for loop for these so that there's a slow movement and we don't create too much torque. Okay, one more time. And now I would be able to leave. And in that way, traffic is being controlled. So this concludes the video for my capstone project. If you have any questions, please leave them in the comments. I, of course, could have missed various things in my presentation. But again, thank you for watching my video, and best of luck to all my viewers. Goodbye.